Hello everyone. Today I am going to discuss the fourth problem of Leetcode Weekly Contest 403, which is find the minimum area to cover all ones 2. So what is the problem? You are given 2D binary array grid. You need to find three non-overlapping rectangles having non-zero areas with horizontal and vertical sides such that all the ones in the grid lie inside three rectangles. Find the minimum possible sum of the area of these rectangles. So the second problem of this contest is quite similar also, but instead of finding three rectangles, we have to find one rectangle. So the problem becomes quite easy. But this problem is something difficult. Okay. Now let's look at some examples to understand the case better. In the first example, here we have to find three rectangles as all the ones are covered. So the first rectangle is the purple one, the second rectangle is the blue one, and the third rectangle is the orange one. So the total area of the rectangles are 2 plus 1 plus 2 is 5. In the second example, here you can see there are three rectangles like that. Here you can see that one rectangle has 0 in it also, because we if we don't take this 0, then we can't take this one. Okay, so the rectangles can also contain 0 in it, but we have to take three rectangles such that all the rectangles are covered. Okay, so all the ones are covered. So how we can solve this problem? So the first observation is from the constants. Okay, on the constants are 30. So the constants are 30. So the time complexity could be order of n to the power 4 or order of n to the power 5. Okay, order of n to the power 4 and order of n to the power 5. So I have solved this problem in order of n to the power 5, but I think there are solutions which are in order of n to the power 4 also, but this will also get accepted. Okay. Now, how I am solving this problem is important. My idea to solve this problem is that I will try to find the area with two rectangles. Okay, let's say we have to find the area, minimum area to cover in two rectangles. So we have some set of ones present. We have some set of ones present, and we will try to find the area such that all ones are covered using two rectangles. Let's say this is the rectangle. These ones are present like this. Then what is the way to get all the ones covered in two rectangles? One possible way is to like this. One possible way to this rectangle and this rectangle, the area will be 4 plus 9 4 plus 16. This is the first possible solution. And what is the second possible solution? Second possible solution is similar, 6 plus 4 10, which will also not work, which will be also same. We don't have any solution which is better than 10, so our answer will be 10. So let's say we have some black box. Let's say we have some black box which solve the problem for two rectangles. Let's call that rect2. Rect2. Let's call that rect2. Now, how we can use this black box to solve this problem in this time complexity? Okay. So for that, we'll select one rectangle. We'll select one rectangle, and after that, we'll remove all the points in that rectangle. We will select one rectangle and we'll remove all the points from the rectangle, and then we'll give those points to this rect2 black box. Okay, we'll give those points to this rect2 black box, and this will solve the problem. Okay, so let's say we have selected some rectangle like this, and after that the rest of the points we are passing it in rect2 p. Okay, now the area of the rectangle plus rect2 p will be our desired answer. So we can choose all the rectangles. So we can choose all the rectangles and do rect2 p, and we will get our desired answer. So for choosing all the rectangles, the overall time complexity will be order of n to the power 4, order of n to the power 4, and our rect2p, let's say the time complexity is order of n square. So overall time complexity is order of n to the power 6, which is definitely not possible. I'll discuss the rect2 part later, but try to first visualize the how we are decreasing the time complexity of the selecting rectangles from order of n to the power 4 to order of n cube. Okay, because if we can do it in order of n cube, then our overall time complexity will be order of n to the power 5. Okay, now how we can select all the rectangles in order of n cube? Then the answer is we don't have to select all the rectangles. We can select only those rectangles which will contain the leftmost one. we will choose all the rectangles which will contain the leftmost ones. Okay, so for that for the leftmost one, let's say we have selected the leftmost column. Okay, let's say we have selected leftmost columns. Instead, let's say this does not contain the one. Let's say this contains one. So this contains one. Now this is the leftmost one. So let's call that LC. Then, and after that, for finding all the rectangle containing this, we have to find three more parameters. Okay, three more parameters. The this is left column. We have to find the right column. We have to find the top row, and we have to find the down row. If we select these three things, if we select these three things, left column is already specified. Then we can define in one rectangle, and all the points within this rectangle will be removed from the points list. Okay, and after that we will solve the problem for two rectangles for the rest of the points. Okay, that's what I have done. I have selected leftmost column, and we have iterated over rightmost row, topmost rightmost column, topmost row, and downmost row in order of n cube, and we have removed the other columns from here. Okay, so we have decreased the time complexity for selecting the rectangles from order of n to the power 4 to order of n cube, and rest of the thing is remaining is that how we can solve this rect2p in order of n square. How we can solve the rect2p in order of n square, that is the question, and we have to solve it. So let's take one rectangle. Okay, let's take one rectangle. Now I will make some observations here. uh, let's say this contains some ones. Let's say this contains one here, one here, one here, one here, one here, one here. Okay, now my observation here is that will be the first rectangle will be in some range, some row. Let's say the first rectangle will be in the left side of this range, and the second rectangle will be the right side of this range. This is a possibility that we are splitting the two rectangles in two horizontal, you can say, using some vertical split. And other possibility is that we are splitting the rectangles, in let's say in horizontal split. We are splitting the rectangles in horizontal split. These two are the possible cases, and there are no two cases combining these two. Okay, there are no case which is combining in these two. Okay, so why I am saying this, let's say we have some rectangle like this. Okay, let's say we have some rectangle like this, and we have ones in this place, this place, this place, and this place. So we can't really combine this rectangle. Let's say one is present here also. Let's say we can't combine this rectangle and this rectangle because they will merge. So one possibility of choosing the rectangles will be like this. We will choose the first rectangle like this. This is one possibility. The first rectangle will be the upper one, and the other possibility is that we are splitting it in horizontally. So the first rectangle will be the leftmost side, and the second rectangle will be the rightmost side. So what we are doing, what I am doing is that we are trying to solve the two rectangle problem in two ways. First, we are trying to do vertical split and try to find the area, and then separately we will try to do horizontal split and try to find the area, and the area will be minimum of these two. Okay, the area will be minimum of these two. Now how we can solve this problem for horizontal split, this vertical split. Let's solve the problem for vertical split. The other problem becomes the reverse of this problem, or you can say if we can solve this from I comma j for a horizontal split, then if we solve the problem for j comma I, it will solve our problem for horizontal split. If this is vertical, then this will be horizontal. Okay, so only one algorithm will be needed to solve the problem. Let's say we are doing some we are solving this problem using the vertical split. Okay, how we are solving this problem using the vertical split, let's find out. So let's say, what is the leftmost row? What is the leftmost row? Leftmost row is nothing but the first one. In the first one is present in the row, that will be our leftmost column. The first one present will be our leftmost column. Let's call that left LC. And for this first rectangle, the current point, let's say we are iterating over points in a sorted order of columns. In the vertical split, we have to iterate over sorted order of columns, and the let's say our this is the leftmost point of the first rectangle, and let's say this is the rightmost point of the first rectangle. Rightmost point of the first rectangle will be the current point we are at, the column of the current point we are at, and similarly the leftmost point of the next rectangle will be the next point, and the rightmost point of the second rectangle will be the last point in the list, because we are sorting the points in the order of columns. Okay, I hope you got it. Now after that we have to find the top and down in this rectangle and the top and down in this rectangle. So let's jump onto the code, you will understand it better. So let's jump onto the code. Right here, this part is to find the first column. Let's jump into the rect 2 part, then I will explain the selecting the first rectangle. So this is the rect 2. So we have some vector of array points. Okay, now here we are taking some columns count. Okay, so uh, in the first column, now number of ones are present, let's say, is 1. In the second column, the number of ones present are 3, and the third column, the number of ones present are 2. The first column here is 0. First column here is 0 because 1 is present at 0th index, and the last column here will be index 2. Okay, that's why first column will be 0 and the last column will be 2. Now top and down, this will determine the top of the first rectangle and the down of the first rectangle. Top is minimum of top comma column and down is maximum of down comma column. Okay, now the area of the first rectangle is row minus current, because current I have told you now that the this value, the first row value will be the rightmost point. Okay, so this is row minus 0.00 plus 1, row minus 0.00 plus 1, and down minus top plus 1. This is the area of the first rectangle. Now we will do columns of col minus minus, columns of col minus minus. Now this value is becoming 0, this value is becoming 0. Now the first column of the next rectangle will not be this one. Okay, because when we are decrementing the value, we are removing the value from the grid. Okay, so until while this is kind of finding the mix, if you solve the problem finding the minimum excluded, this is similar to the approach is similar to that. While columns of fc equals to 0, we are incrementing the value of fc. Similarly, where the columns of the last column is equals to 0, we are decrementing the value of lc, last column. Okay, now this part, if the point is the last point, then we are doing answer equals to minimum of answer comma area plus 1. Why we are doing that? Because we have to take two rectangles only. So if we are taking all the points in the first rectangle, we can't really do that. We have to take any one point else. Okay, that's why we are doing area plus 1. And otherwise we are taking L as the first column and R as the last column. Here first column and last column I have told you now, we are doing this. And the uppermost point will be points I plus 1 comma 0, the row. If we are sorted in row order, then it will be the row of the current row of the I plus 1th element, and the last row will be the row of the last element. Okay, uh, this is for when we are doing some horizontal split. Okay, this is when we are doing some horizontal split. Okay, I hope you get it. Now the area will be, the area of this second rectangle will be r minus l plus 1 into d minus u plus 1, and answer will be minimum of answer comma area. I hope you get it. This is solving the problem for I think yeah. Okay. This is solving the problem for, I think, we are doing columns of col minus minus. Mm, columns of col minus minus. This is one column, right? So here we are iterating over the rows, iterating over the columns, So this code is for the horizontal split. This code is for the horizontal split. Uh, for the vertical split, we have to find the row count instead of column count. We have to find the row count. Okay. Now you can rewatch this part. You will understand what I am trying to say here. Now let's jump into the section of selecting the first rectangle. So the first rectangle we are selecting is we are selecting the first column. Here we are selecting the first column, which will be the leftmost one, right? And we are iterating of the second row, second column, first row, and the second row. And the rectangle will be enclosed between first row, second row, and first column, second column. The area will be second row minus first row plus 1, and second column minus first column plus 1. Now we are we are solving this problem separately for the horizontal split and the vertical split. For horizontal split, we need based on to the we need the pairs sorted on the row first order, and for vertical split we need the points sorted onto the column first order. That's why we are doing this. You can do this in uh, do this in single n square loop, but that's after that you have to sort the row first and column first. But as we are iterating over I here first, that's why this pair I comma j will be sorted, and here we are iterating over j first, that's why j comma I will be sorted. Okay, then our 2 will be minimum of the horizontal split and the vertical split, and your answer will be minimum of answer comma area of the first rectangle and area of the solving the rect 2, the our black box. Okay, that's why answer will be minimum of answer comma area plus 2. Okay, this this problem is quite interesting, and I think there are better solutions than this on time complexity, but this will also work. If you have any doubt in any part of the explanation, you can always ask in the comment section. I will provide the link of the problem in the description box, link of the code in the description box. If you like this video, please like the video and subscribe to the channel. Thank you.